In exercise 2a, we will explain gradient boosting, and we will explain how it is different from AdaBoost. So the biggest difference between gradient boosting and AdaBoost is that the weak learners, except for the very first weak learner, regress not on the target Y, but on the pseudo residuals of the previous weak learner. Okay, so the first the first weak learner regresses normally on the target. This learner then produces residuals, and these residuals, so the difference between the actual values and the predictions of the first model, are used then as the targets for the second model. Okay? So the final model, let's assume it's a tree-based model. Will just be the sum of the trees. So no averaging over the trees, no amount of say weighing. So this tree is our weak learner, or these trees in sum then are our weak learners. And this you should already be familiar with. This is the average of the regions. So let's note down this still. So how does this actually work now? Maybe it's not that intuitive, but I will try to make it more visible. And I wouldn't consider this example that I will give now to be um, scientifically accurate in any way, but I think it might be a very good way to think about what is happening here. So why we will actually regress on residuals, because this is a strange idea. Okay, so let's just assume that this point here is just some point that is the true value for y. Okay, and now let's assume that we made a prediction with our model which lands here. Okay, so this is our best guess for this y hat. So this means that we now get a residual or pseudo residual. I don't really know why it's called pseudo residuals, but that's somehow in this context you call it pseudo residual. So this should be delta. Okay, so now we will take our approach from above that we noted down here in formulas, and we will use delta as the target variable when fitting the next weak learner. So now this, let's draw again. So this was our, let's just bring this down here. So this would be basically our prediction from before this fitting of the second model. And this would be the y value, so the true target. And now we have the prediction from t. So let's make this maybe black. So from this tree that we fit on our delta. And this prediction will, so what does this actually mean? This will yield something like a delta hat. So an estimate for this delta, because we used this tree to predict the delta. That means we get an estimate for the delta. So this will be now something like this big of a distance. And now, when you think about it, this will yield us our new estimate that will be at this point here. So let's just draw it again. This would be y. So it should be on the same level. This would be our old gas from the learner before fitting on the residual. So we actually got closer to this true value of y by having our old model and just summing up the old model and the new model, or the second weak learner that we have regressed on the residual. So this is just the sum of both predictions that will then move us closer to the actual value. Okay, this is how we actually, so it's a bit twisted, because you have to think, okay, why do we now regress on a distance, but we want to get in this direction. So this is how I, for myself, visualize it, so that we have this old prediction from the previously fit learner. Then we take the distance between that, so the error, the residual, and we use that residual for a new model, a second model, that should predict our residual, and then we sum the prediction and of the second model that was trained on the residual and the previous model that predicts y, and this will give us a new y that, or prediction for y, that moves us closer to the actual y value. So this is gradient boosting in short.